All right, students, so this is going to be the example 1, explain 1, part A, and it comes from lesson 19.2. I'm going to go ahead and show you the logic behind how to do vertical translations. Vertical being the key word. Remember, what kind of moves can you do on the vertical axis? You got one of 3 moves. You could either go up if it's positive, down if it's negative, or stay if it's 0. So the first thing we do is we notice inside this little box right here, it has a few little things written down. I need you to put me on pause and write that down exactly how you see it, so you could use it to reference it for part B and your turn, along with the homework assignment. So put me on pause and write all that down. Okay, so let me kind of paraphrase what it's saying. The graph of a function f of x is equal to x squared plus k is the graph of the function f of x, x squared, which is the parent function. Remember, this is the one where nothing is being added, subtracted, multiplied, or divided to the x squared. Because now we are doing something with a k, we are doing a vertical translation. Now, if the k is bigger than 0, in other words, all whole numbers bigger than 0, basically that would be your counting numbers, your natural numbers, 1, 2, 3, 4, all the way up to positive infinity, you're being translated up. If k is smaller than 0, now, things that are smaller than 0 are all negative numbers. If that's the case, then you are being translated, notice what it says, absolute value of k units down. So if k was negative 5, the absolute value of negative 5 is 5, so you would go down 5 units. Okay, so looks like the first thing they want us to do is they want us to graph, find out if it's a max or min, and what is the axis of symmetry. All right, so here we go. First things first, you'll notice you have 2 separate functions. You have f of x equals x squared, nothing being added, subtracted, multiplied, or divided to the x squared, so this is the parent graph. Then the second one they want you to do is g of x. G of x is equal to x squared plus 2. Now, just as a quick reminder, how do you do the algebra on g of x? Well, if it's g of x equals something being squared plus 2, then anywhere I see an x, the first number you notice they plugged in was negative 3. That means I come over here and do negative 3, negative 3. Okay, here's where you have to be very careful because you're trying to do PEMDAS on multiple operations. So first things first, look in the parentheses, P. If there's nothing to be done in the parentheses, move to your next letter, E, exponents. Okay, so if I do negative 3 squared, I get negative 3 times negative 3, which is 9 plus 2. I am now done with exponents. I look for multiplication, division from left to right. I don't see any. So now I do addition and subtraction, and that means g of negative 3 is going to equal 11. That's your math. Luckily, somebody did all the math for you. So now all we have to do is take these ordered pairs and plug them into Desmos along with our functions so that we can see what is happening. All right, I'll go ahead and put me on pause, write all these numbers down. Remember, they're ordered pairs. So this negative 3 goes with this 9, but then this negative 3 is also going to go with this 11. So you're going to have 2 sets of ordered pairs. You're going to have f of x equals x squared. Your first ordered pair is going to be negative 3 comma 9. But then for our second function, we're going to have g of x equals x squared plus 2. And for our first order pair, we're going to have negative 3 comma 11. All right, go ahead and finish out the table of your ordered pairs. And by the way, before you get too ahead of yourself, remember we're going to need to set our graph settings. That's the little monkey wrench in Desmos. So for our graph settings, we better go ahead and write this down just to make sure we got it straight. Notice it's starting right here and it's ending right here. Remember, this is not the domain and range, this is graph settings. So it looks like I'm counting by ones. So for my X settings, I want to start at, excuse me guys, I want to start at -7 and run all the way through all my X's until I hit +7 with steps of 1. Then for my Y's, I want to repeat the same thing. I'm down here, I need to see this. I'm up here, I need to see this. Looks like here I'm also counting by ones, so I'm going to start at -5 and I want to run all the way through all my Y's all the way up until I hit 11 with steps of 1. All right, once you get everything written down, go ahead and hit resume and watch the rest of the video as I graph this on Desmos. Okay, everybody, let's go ahead and go to Desmos. First thing we want to do is take off minor grid lines. Now, since we don't have a title, we're going to go ahead and reset. Now, if I remember correctly, it was -7 all the way to 7 with steps of 1. My y-axis had no label, but it started at -5 and ran all the way through 11 with steps of 1 as well. So, this should look just like the little graph that I need right here. All right, so now we're going to start with our first table. So our first table had the ordered pairs of -3, 9, -2, 4, -1, 1. Okay, that's supposed to be -1, 1, 0 at 0, 1 at 1, 2 at 4, and 3 at 9. Now, if you look really closely, doesn't it almost look like all these dots should connect and make a perfect symmetrical line? Okay, it looks like I'm missing one. Missing one, right? See this ordered pair right here, which is 0, 4. If I go 1, 2, I should have 1, 2, 1 right here as well. So it looks like I'm missing my -2. So I'm going to come over here and realize, hey, look, I did the same mistake twice. It's supposed to be a -2. That's how you know you did something wrong. Okay, now I want to connect my line. So this was my parent function, so all I need is x squared. And look, everything lines up perfectly. Now, just to keep everything simple, I'm going to change the color of this line to green as well. That way they all match up. Okay, now I'm ready for my second table. So my second table, which it's wanting to do green, but I'm going to change it to something other than green. So let's change these to red. Okay, here we go. By the way, all I did was I put my mouse on it, held my left mouse button, and it opened up the windows with the different colors and the lines. Okay, so for this one, we're going to do -3, 11, -2, 6, -1, 3, 0 goes to 2, 1 went to 3, 2 went to 6, and finally 3 went to 11. Now, if you look really close, it looks like it stretched. Looks like it stretched a little bit, but in reality, it didn't. Okay? In order to see what it actually did, we're going to have to come over here and put a x squared plus 2. Okay, it did capital X and it didn't like it, so it has to be lowercase x squared plus 2. Now, it didn't really stretch. What it did is it translated vertically up 2 units. So if I look at my original, right here, my original vertex, notice my vertex went up 2 units. I hope you see this, because if I could somehow grab this black line, and let's change the line to red, just to make it look the same. No other particular reason other than that. So I'm going to hold it, change it to red. Now, if somehow, and I can't, but if somehow I could grab this line and drag the whole thing down here, you'll see that it'll lay right on top of the green line. It is the exact same graph. The only difference is it went up twice. So now we come down over here and we realize that the function of g of x, x squared plus 2, has a minimum value of 2. How do we know it's a minimum value of 2? Well, first of all, did you notice a was equal to a positive? Since a is equal to a positive, it opens upwards. The lowest point on the y-axis that this thing hits is right there at 2. That's why we say it has a minimum value of 2. Okay, for my axis of symmetry, I gotta grab a copy of this. Give me a second. Wait, I don't like that copy. I want this copy. I want more lines on it. There you go, that's better. And for my axis of symmetry, and I hope you can see this clearly, if I were to take a line and cut the thing perfectly in half, where, and remember, axis of symmetry is an x value, and I'm going to move this over just a little bit because it's not going to let me do this. The axis of symmetry is an x value, where if you were to draw an imaginary line and cut through the x, where does it cut through the x at? Well, this one looks like if you were to cut through the x, it would be at 0 right here. Okay. All right, so now we come back and we confirm everything we suspected. We're going to be going ahead and working on part B here in just a second. So what I'd like you to do is to try part B on your own. And once you are finished, go ahead and go to the part B video.